Good morning, grade 9s. Today we're going to look at the second type of factorizing, which is called difference into squares. Now the name tells us exactly how the expression that we need to factorize is going to look like. There's going to be a difference, in other words a minus, in between two squares. And a square is any term that I can take the square root of. For example, 4 is a square because I can get the square root of 4, that is 2. Or x squared is a square because I can get the square root of x squared, which is just x. Okay, but before we start, I would like you to pay attention to what I wrote here in blue. If we have to multiply that brackets out, how am I going to do that? I will say that x times x is x squared, then x times a positive y will be a positive xy, then this negative y times x will be a negative xy. Remember, we write it in alphabetical order. And then lastly, this negative y times y will give me negative y squared. Okay, now if we have to simplify this expression here, we will see, you will see that these middle two terms will cancel out because one xy minus another xy is just 0. So the answer of this expression when we multiplied it out will be the answer in this orange block, x squared minus y squared. So what we're going to do today is we are going to do the reverse of this sum. We're going to take this x squared minus y squared, the one that's in the orange block, and we're going to factorize it so that it looks like that top expression again. Okay, so let's start by looking at these 4 examples. Okay, what I wrote here in purple in capital letters is always first look for a common factor. That is the first type of factorizing that we did a few days ago. So please always first look for a common factor. But if you look at the first example, 4m squared minus 25, there's no common factor that I can take out between these two terms. So then I'm going to use the second type of factorizing, which is difference into squares. And let's look here. There is a difference, and it is 2 square numbers. Okay, I can take the square root of both of them. So how this thing will factorize is as follows. It will factorize in 2 brackets, so you can write that. The one will be a positive, the one will be a negative. It does not matter in which order you wrote it. If you first put the negative and then the positive, it will be correct as well. So now you do the following. In your mind or somewhere in pencil, please don't do it where you do the sum. You take the square root of the first term in your mind or in pencil somewhere. What is the square root of 4m squared? That will be 2m. So 2m will be the first term in both of those brackets. Okay? Then you take the square root in your mind of the second term. What is the square root of 25? That is 5. So 5 will be the last term in both your brackets. And then you are done. Please don't multiply those brackets out again. That's not necessary. It says factorize, so that's your answer. Okay. Let's look at question number 2. Is it at all possible to take the square root of 18? Definitely not. So now I know there's something else that I need to do first. Okay? I said always first look for a common factor. And is there a common factor that I can take out between these two terms? Definitely. And that is 2. That is the highest common factor that I can take out. Now remember we said if I take out a common factor, and I must determine what's left inside the brackets, I take the first term and I divide it with the common factor that I took out. And 18 divided by 2 is 9, and the x squared will be left. All right? Now you take your second term, which is 8y squared, and you divide it with the common factor that you took out. And 8 divided by 2 is 4, and the y squared will be left. Okay. But now if you look at this bracket, that can still be factorized further because it's difference into squares. So just drag this 2 along, and now I know the difference in two squares will factorize into two brackets. One will be a positive, one will be a negative. And now in your mind, you take the square root of the first term. So what is the square root of 9x squared? That will be 3x. So 3x is the first term in both my brackets. Now you take the square root of the second term in pencil somewhere or in your mind. And what is the square root of 4y squared? That will be 2y. So 2y is the last term in both your brackets. And I'm done. All right, question number 3, or example 3. This x to the power of 4 is a square number because I can get the square root of x to the power of 4. And can I get the square root of 1? Definitely. So I know that I can factorize this by using difference in two squares. All right, so it will factorize into two brackets. One will be a positive, one will be a negative. In your mind, you take the square root of x to the power of 4, and that's going to give you x squared. So x squared is the first term in both your brackets. And then in your mind, you take the square root of 1, and the square root of 1 is just 1. So 1 will be the last term. Oh, sorry, there must be a square. 1 will be the last term in both your brackets. Now I would like you to pay attention to this bracket here. Don't you think that it is at all possible for that bracket to factorize again because of difference into squares? Definitely. So this first bracket I'm going to keep as it is. Don't throw it away. Please remember to write it. X squared plus 1, it will stay the same. That x squared plus 1 cannot factorize further because it's not difference into squares. Okay? But this one here will factorize into two brackets. One will be a positive, one will be a negative. All right? Now in your mind, you take the square root of x squared. What is that? That is just x. So x will be the first term in both my brackets. And then in your mind, you take the square root of the second term, and the square root of 1 is just 1. So 1 will be the last term in both my brackets. Okay, that's your answer, just like that. If you look at question number 4, sorry, this is a mistake here, that should be a 4. Okay, we have 100p to the power of 6 minus a quarter x squared. Guys, we have a difference in two squares here, so we can factorize it. It will factorize into two brackets. One will be a positive, one will be a negative. It doesn't matter in which order you put it. And then in your mind, you take the square root of the first term. What on earth will the square root of that 100p to the power of 6 be? The square root of 100 is 10. The square root of p to the power of 6 is p to the power of 3. So 10p to the power of 3 is the first term in both my brackets. Now you take the square root of the second term, and now we have a fraction there, but please don't let that bother you. What is the square root of a quarter? That is just a half, and the square root of x squared is x. So a half x is the last term in both your brackets. Okay, we would like you to please do exercise 16.4. It is on page 180, but please do everything. You can only leave out question number 3D. All right, so the teacher that's invigilating in your class, please pause this video, let the learners do this exercise on their own, and then come back to mark it. Okay, welcome back. Let's factorize this question number 1a. There's definitely nothing that is common between both in both those terms. So then I can factorize it by using difference into squares because there is a difference and we have two square numbers. So it will factorize into two brackets. One will be a negative, one will be a positive. It doesn't matter in which order. Now in your mind, you take the square root of the first term, and the square root of x squared is just x. So x will be the first term in both my brackets. And then in your mind, you take the square root of the second term, which is the square root of y squared is just y. So y will be the last term in both your brackets. And that's your answer. Question B. There's nothing that is common that I can take out. It's definitely difference into squares, so it will factorize into two brackets. One will be a negative, one will be a positive. Now I take the square root of the first term in your mind somewhere, and the square root of 9x squared is 3x, so 3x will be the first term in both your brackets. And then you take the square root of the second term, which is 16, so the square root of 16 is 4. So 4 will be the last term in both your brackets. And that is the answer. In question C, there is nothing that is common that I can take out between those two terms. It's definitely difference into squares, so it will factorize into two brackets, one a negative, one a positive. In your mind, take the square root of the first term, and the square root of 4x squared is 2x. So 2x is the first term in both my brackets. And what is the square root of the last term? It is definitely 5. So 5 is the last term in both your brackets. Right, 1D. Nothing that is common in the terms, so it's difference into squares, definitely. It will factorize into two brackets, one a positive, one a negative. Right, now the 25 is the first term, so please don't write the term with a y first in your brackets, okay? So, what is the square root of 25? It is 5, so 5 is the first term in your brackets. And then, what is the square root of 36y squared? That is 6y. So, 6y is the last term in both your brackets. Can you see that the brackets looks exactly the same? Just the signs is different in both brackets. One is a negative, one is a plus. In all of the examples we've done so far. All right, let's look at number 2a. Is there something that I can take out common? Definitely not. Can I use the method of difference into squares to factorize this expression? Yes, we can. So we can factorize it in two brackets, one a positive, one a negative. And now you take the square root of the first term. The square root of 25x squared is 5x. So 5x will be the first term in both your brackets. And the square root of 1 is 1. All right, so 1 will be the last term in both your brackets. 2b, there's nothing that I can take out common. It is difference into squares, so it will factorize into two brackets, one a positive, one a negative. Take the square root of the first term, and the square root of 4x squared is 2x, so 2x is the first term in both your brackets, and then take the square root of 81, and that's going to give me 9. So 9 is the last term in both your brackets. Let's look at question 2c. 144 minus 121y squared. There's nothing that I can take out common between those two terms, so I can use difference into squares because it is a difference and it is two square numbers. Alright, so it will factorize into two brackets, one a positive, one a negative. Now you take the square root of 144, and that is 12. So 12 is the first term in both your brackets. And then you take the square root of 121y squared, and that will be 11y. So 11y is the second or last term in both your brackets. 2d, it is difference into squares that I can use to factorize this. It will factorize into two brackets, one a plus, one a minus. Take the first term's square, and that's going to give me 4x. So 4x is the first term in both brackets, and then take the square root of 49y squared. That's going to give me 7y. So 7y is the last term in both my brackets. All right, pay attention here at question 3a. Can I get the square root of 32, for instance? Definitely not. Can I get the square root of 2? No. So I first have to see if there is not something that is common in both these terms. And there is. I can take out a 2, okay? So if I take out 2, I still need to go find what's going to be left in the brackets, okay? How do I do that again? I say 2x squared, the first term, divide by 2, and what's left then? Only the x squared, keep the negative, all right? And then you say 32 divide by the common factor that you took out of, which is 2, so 32 divided by 2 is 16, keep the negative in between, okay? And now if you look at this bracket there, that can factorize even further by using difference into squares, okay? But please don't let this 2 bother you here in the beginning. Just drag it along, okay? So keep it there. And now this bracket x squared minus 16 will factorize into 2 brackets, one a positive, one a negative. Now you take the square root of the first term, and the square root of x squared is x. So x is the first term in both your brackets. And now you take the square root of 16, so 4. Because the square root of 16 is 4. So 4 will be the last term in both your brackets. Alright, 3b is the same as 3a. There is something common in both those terms that I first should take out, and that will be 5. So if I take out 5, I still have to determine what's going to be left inside the brackets. 5x squared divided by 5, you take the first term and you divide it with the common factor that you took out. And then the 5 and 5 will cancel, so it's only the x squared that's going to be left. You keep the minus, and then 20y squared divided by 5 that you took out will give me 4y squared. Now this bracket here, if you look at that, it is difference into squares. That I can use difference into squares to factorize that. Okay, just drag that 5 down, and now that bracket can factorize into 2 brackets, one a positive, one a negative. Now in our heads or somewhere in pencil, you take the square root of x squared, which is going to be x, first term, which is the first term in both brackets. And now you take the square root of the last term, and the square root of 4y squared is 2y. So 2y is the last term in both brackets. All right, last question. x to the power of 4 minus y to the power of 4. That is difference into squares because there's nothing that is common that I can take out, okay? So it will factorize into 2 brackets, one a positive, one negative. What is the square root of x to the power of 4? That is x squared. So x squared is the first term in both our brackets. And then what is the square root of y to the power of 4? That will be y squared. So y squared is the last term in both our brackets. But look at this bracket here. Isn't that also an example of difference into squares? I think so. Keep the first bracket, guys. We can't throw that away. It can't factorize further because there's a plus, but just keep it. And now this bracket here can factorize into 2 other brackets. One a positive, one a negative. It doesn't matter in which order you put it. Now take the square root of the first term. So what is the square root of x squared? It is x, so x is the first term in both those brackets. And now you take the square root of y, and that is going to be y. So y is the last term in both your brackets. And I'm done. Please feel free to ask us if you're still uncertain about something.